Okay, so we also discussed in the previous lesson about symmetry, and we talked about symmetry with respect to the y-axis, x-axis, and the origin. And we also talked about even and odd functions. When we talked about even and odd functions, we mentioned that an even function is symmetric about which one? Symmetric about the y-axis. An odd function is symmetric about the origin. And sometimes directions say determine if the function is even, odd, or neither. So if it's neither even nor odd, you would say neither. A function cannot be symmetric about the x-axis because it's no longer a function. We saw that yesterday. So when we talk about functions, even or odd, it's only symmetrical about either the y-axis or the origin. But when we talked about this graph right here, you can look at this and say that it's what kind of function? Even, because it's symmetrical about the y-axis. We had that discussion yesterday. But we also discussed this yesterday. It was on your in-class quiz or your in-class worksheet that this point here, right here, and that's the point 2, 4. So if that's an even function, then what other point needs to be on that graph? Negative 2, 4. Because remember, it's symmetrical about the y-axis. So we talked about distances. So just go back in the notes from yesterday and look at that. We talked about distances. So the symmetry about the y-axis. So this point here, negative 2, 4, better be on that graph as well. So if this point right here, I'm just going to call it x, y. So if x, y is on the graph of an even function, then what other point needs to be on that graph? Negative x, y. All right? And if I'm calling this function right here, f of x, I'm calling that function f of x. Remember, f of x stands for the same thing as what letter? Y. Then I can also replace this right here as x comma what? F of x. Because remember, y means the same thing as f of x. And I can replace this right here as negative x, and what's y? F of x. Okay? All right. So that idea right here about this, on an even function f, if f of x is on the graph, then negative x, f of x needs to be on that graph as well, will come into play in a little while. When we're talking about an odd function, so that was even. So notice, I want you to notice, you see this x, you see this negative x. For both of those, I ended up with f of x, right? Okay, x, negative x, I ended up with f of x. Both of these were y's. Y, same y value, right? Okay. When I look at this function we saw yesterday was what kind of function? It was an odd function because it's symmetrical about the origin. And we saw all that discussion I went into it. So if this point here, and let's say this is 2, and let's figure out what this is. On you can't see it up here, but on your paper it says negative x cubed plus 5x. So if I substitute 2 for x, what's 2 cubed? So I'm trying to find f of 2. So f of 2 would be negative 2 cubed, right? plus 5 times 2. What's 2 cubed? 2 cubed? 8. So that becomes a negative 8. Plus 10. So that becomes 2 what? 2. So we saw yesterday that if if the point 2, 2 is on the graph of an odd function, then what other point needs to be on that graph? Negative 2, negative 2. Okay, negative 2, negative 2. So remember the idea that it's symmetrical about the origin. So this distance is the same as that distance from the origin. So basically, on that in-class worksheet, if the point, if negative 3, I'm going to try and figure this thing out. What's negative 3 cubed? So it's negative 27. So that's going to become, basically be this, right? Negative 27 plus 5 times negative 3, correct? So that becomes a 27 plus a negative 15, which is what? 12? Is that right? So if the point negative 3, 12 is on this graph, then what other point needs to be on that graph?
3, negative 12.
Then 3, negative 12 is on the graph. All right, and it is. All right, so we saw that yesterday. Remember, we're talking about this function here, which is represented by this expression. So in general, we saw this. We saw that if we have xy on the graph of an odd function, then what other point needs to be on that graph? Negative x, negative y. So negative x, negative y. All right. Now remember, we're calling this function f of x. So that's the same thing as what letter? Y. So this right here I can write as x comma what? F of x. And this right here, I can write as negative x comma negative f of x. Very good. Okay, so that's going to be important when we talk about something in a little while. Okay? All right, and then remember this right here was an odd function, and this right here was what kind of function? Even. But then at some point when we're talking about symmetry, we looked at this relation. Now, that's not a function, right? Because it fails the vertical line test, so that's not a function. But it does have symmetry. What's the symmetry? The x-axis. All right, so we saw yesterday that if the point, and this is 5, 3, if the point 5, 3 is on the graph, I'm not using the word function, it's not a function. If the point 5, 3 is on the graph of a relation that's symmetrical about the x-axis, then what other point needs to be on that graph? 5, negative 3. If the point, let's see, this one, let's do this one. If the point negative 3, 1, that's a 1, is on this graph, and it's symmetrical about the x-axis, then what other point needs to be on that graph? Yeah, so you get that. So compare this graph, which is symmetrical about the x-axis, with this graph that's symmetrical about the y-axis, and notice what changed. So here, if the point 2, 4 is on the graph that's symmetrical about the y-axis, then what other point needs to be there? Negative 2, 4. So just think that all you're doing is just reflecting about the y-axis. So the height, y, stays the same. It's the x's that change. Over here, you have 5, 3. This becomes what? 5, negative 3. So when you reflect about the x-axis, the x's stay the same. What change? The y's. Okay? All right. So in my math lab, there's a question about what we just discussed. So if the point, I'm going to call this xy right here. If the point xy is on the graph of a relation that's symmetrical about the x-axis, then what other point needs to be there? X negative y. Okay? All right, so there's like 3 questions that on my math lab that talk about x and y and what does it become. All right, now, listen to this. We talked about, if I go back to this even function, right here, this is even function, we saw this. For an even function, for an even function, for an even function, do y'all agree? Remember this is f of x, right? This is my function f of x. So do y'all agree that f of x will be the same, now we're going to discuss this, as f of negative x? All right, so here's x. How do I find my y value? I find what? F of x. Just like when I said if x is 2, how do I find my y value? I find f of what? F of 2. So over here, if this is negative x, then I'm going to find what? F of negative x. But what do you notice about those 2 y values? They're the same. So f of x better be the same as what? F of negative x. And it makes sense because watch. What is f of 2? 4. What is f of negative 2? 4. So f of 2 is the same as what? F of negative 2, right? So f of 11 better be the same as what? F of negative 11. So f of x better be the same as what? F of negative x. And that's that point that I was making here. So if you have an even function, then f of x better be the same as what? F of negative x. Okay? For an odd function, let's discuss an odd function. All right, so this part carefully. All right, let's go to that odd function. All right, this was our odd function up here. It's symmetrical about the origin. And we're going to look at it in terms of that, in terms of what we did here, where we said f of 2, f of negative 2, f of 11, f of negative 11, and so on. Let's discuss it like that. So if I find f of 2 for this odd function here, okay, it was equal to what? 2. Okay. Y'all agree? F of 2 is equal to 2. If I found f of negative 2, it was equal to what? Oh, no. Negative 2. Okay, remember, it's an odd function. So if 2 is on the graph, then what other point needs to be on that graph? Negative 2, negative 2. So if f of 2 equals 2, then f of negative 2 better equal what? Negative 2. Okay? We found another one. It was negative 3. If f of 3, well, let's do this. F of negative 3 we found to be what? 12? Y'all agree? Then f of 3 better equal what? Negative 12. Because remember, f of negative 3 equals 12 means what point? Negative 312. So if it's an odd function and the point negative 312 is on the graph, then what other point needs to be on the graph? 3 negative 12, which is what this is. So then I want to ask you this. Right here, let's go to this one right here, where I had f of negative 2. Do y'all agree? Now look at the notation. Do y'all agree that f of negative 2 is the same as negative, and then 2. See, this is negative 2 right here, right? I'm pointing to. See this right here? Well, isn't that this right here? Which is what? F of 2. Okay? So f of negative 2 is the same thing as negative what? F of 2. So f of negative 3 is the same thing as saying, see, this is 12, right? Y'all saw this is 12, right? Okay. Let's see. Do I want to do this one? Let me do. Oh, let's do it this way. I'm going to do it this way. F of 3. Let's do it this way. F of 3 is negative 12, correct? But this 12 is this right here, which is what? F of negative 3. Y'all agree? All right. Now, listen carefully to this part. So the odd one's a little bit more difficult to deal with. You got a sheet of paper you picked up. Now, you know, when I just realized that when I did negative 12 right here, I said f of 3 was negative 12, and I circled that 12. I forgot to put the negative right here. So negative, and then 12 is what? F of negative 3. So in general, I want you to see this. If I have f of x, then that's going to be the same as negative what? F of x. Okay? All right, so that's the one I wanted you to make. All right, now listen carefully. On my math lab, now this will not be on a test, it will not be in your final, but there are 3 questions on my math lab that's going to ask this. When we talk about those 3 questions, we're going to look at what those 2 statements right here, these ideas. This one, and then this one. All right, so for an odd function, f of x is the same thing as, say, negative f of x. Okay? All right, we're going to look at these 2 statements. I keep messing this up. There should be negative x right here. Make sure you write as f of x equals negative f of negative x. That should be f of negative x. All right, so listen carefully. In both cases, see there's an x and there's a negative x, correct? Say it again? All right. So to determine if a function is even or odd, okay? Replace x with negative x. See, both cases, you see an x. You see an x, and what else do you see? A negative x. So go back to your original function. Where we see the variable x, and replace it with what? Negative x. And then compare the result. Then compare the result. Okay? All right. So you basically all you do, and remember, this is not going to be in a test, but I am going over because it is on my math lab, and there are 3 questions. So when you do the my math lab, make sure you look at those 3 items that I'm working on. All right, the first one is going to ask you this. I don't know if it's going to give you the same function, but this is the one that they have. The question is this. Determine whether g of x, which equals x to the 6 plus 3x. Let me do this. I'm sorry. I'm so sorry. H of x, which equals 2x squared plus x to the 6. I'm going to do that because it's going to be a little bit easier to deal with. So that's 2x squared plus x to the 6. Determine whether h of x equals 2x squared plus x to the 6 is even, odd, or neither. And we're going to do this algebraically. Now, based on our discussion yesterday, you know the answer to it. Do you remember our discussion yesterday? How do you know it's even, Jordan? Because of the exponents. All the exponents are what? Even. So this could be an even function. If you were to graph it, it would be symmetrical about the y-axis. All right? But you also need to know how to do it algebraically. So to do it algebraically, that's where you replace x with what? Negative x. So let's replace x with negative x. So that means I got to find h of what? Negative x. So where we see the variable x, what do you plug in? Negative x. I get 2 times negative x squared plus the negative x to the 6th power. Now, at one point a while back, we found h of negative x, g of negative x, k of negative x. It was a while back because it was one of the worksheets. So you did something like this. But then at that point you asked yourself, well, what is a negative x squared? So meaning, what is a negative x times itself? What is it? X squared. So this becomes 2x squared, right? So it becomes 2x squared. Well, what is a negative x to the 6th power? Meaning a negative x times itself 6 times. It's x to the 6. So that's h of negative x, right? So h of negative x is 2x squared plus x to the 6. But what do you notice about 2x squared plus x to the 6? It's the same as h of x. That's equal to h of x. So h of negative x is the same as what? H of x. And if you go back to our discussion earlier, if f of x is the same as f of negative x, then it's what kind of function? Even, so it's symmetrical about the y-axis. So basically it's this. If you replace x with negative x, and the function becomes the same as the original, if you replace x with negative x, and the function is the same, and the resulting function as the original, then it is even. Okay? All right. But you know it had to be even to begin with because the exponents, all the exponents are even. All right, let's look at this one. Determine whether f of x, which equals x to the 5th plus 4x, is even, odd, or neither. based on our discussion yesterday, you could probably tell me the answer right away. It's odd. Because what do you notice about all the exponents of the variables? They're odd. Now remember yesterday we saw this as well. If I had this, now listen carefully, and you remember what we talked about yesterday. If I had h of x equal x to the fifth plus 4x plus 2, would it still be odd? It would be neither. Because remember, I can write 2 as 2 times x to what power? 0. So I can write this as x to the fifth plus 4x plus 2x to the 0, and I'm going to ask you, are all of these exponents odd? No. So if you have a mixture of odd and even, then you say neither. So adding a constant, remember when we did that x cubed and moved it up, it was no longer symmetrical by the origin? Okay, so you got to remember some things visually that we talked about to help you with this. But let's do it algebraically. Let's do it algebraically. So I'll replace x with what? With negative x. So that means I got to find f of negative x. So whenever we see the variable x, what do I plug in? Negative x. So that becomes negative x to the fifth plus 4 times negative x. Well, what is a negative x to the fifth the same as? Is it the same as x to the fifth? Negative x to the fifth. A negative times a negative times a negative times a negative times a negative is a negative. A negative number raised to an odd power is always going to be what? Negative. A negative number raised to an even power is always going to be positive. So this becomes negative x to the fifth. What is 4 times a negative x? Negative 4x. All right, now listen carefully to this. So this right here is f of negative x, right? All right. Now, could I also have done this? Now listen carefully. Could I, at this point, factor out a negative 1? We talked about factoring last semester. Could I take out a negative 1 here and write it as negative 1 times x to the fifth plus 4x? All right? But what is x to the fifth plus 4x? The original function, which is what? F of x. So f of negative x is going to be the same as the opposite of what? F of x. All right? Which goes back to this part here. See where I had f of x equals the opposite of f of negative x? So if I divide both sides by negative 1, that means the same thing as this. F of negative x is negative f of x. Just changing the signs, multiplying both sides by negative 1. And that's what this is. F of negative x is negative f of x. So remember that if it was even, replacing x with negative x, every term is identical. If it's odd, replacing x with negative x, what do you notice about every term? X to the fifth became what? Negative x to the fifth. Positive 4x became negative 4x. So every term, the sign change is what I'm trying to get you to say. So if replacing x with negative x produces terms which are opposites of the original, then it is an odd function. An odd function. All right, and then finally, let's look at this one. Or suppose I had this one. G of x, so determine. So remember, if replacing x with negative x produces terms which are opposite of the original, then it's an odd function. So f of negative x becomes the opposite of f of x. So remember, this means the opposite of f of x. So if I go to f of x, what's the opposite of x to the fifth? Negative x to the fifth. What's the opposite of 4x? Negative 4x. All right, so these are opposites. Then f of x is what kind of function? Odd function. All right, this one, determine if g of x, which equals x to the 6 plus 3x, is even, odd, or neither. And by the way, in the one we just did, since it was an odd function, it's going to be symmetrical about the origin. Okay, so right away, you can, based on our discussion from yesterday, you can tell me something about this function g of x. It's neither. Because one exponent is even and the other exponent is odd. All right, so if you were to graph it, you would see that it would not be symmetrical about the y-axis or the origin. All right, well, let's do that algebraically. So we're going to replace x with negative x. So I got to find g of negative x now. So g of negative x equals negative x to what power? 6 plus 3 times negative x. What is negative x to the 6? X is 6. What's 3 times negative x? All right, so that was g of negative x. That's what I just found. Now what you do now is compare this with the original. Compare that with the original, just like the other two. Are the terms the same? No. But my question was, are the terms the same? The answer is no. Are all terms opposites of each other? No. So you say what? Neither. So g of x is neither even nor odd. Okay? All right, so there are three, and those are actually the three. I don't know if they're going to change the exponents or whatever they may do, but this is how we do it. All right, so I did it with you because it's not going to be on your test, not going to be in the final. But it is on my math lab, and we're done with this section. All right, so most